Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Household Circuit. In that part B, some essential components of housing wire system. So before starting our first question, my suggestion is watch the concept video first. So once you understand the concept, then solving all these questions will be very easy for you. So watch it first, then this will be very easy for you. So without wasting any time, we'll start with our first question. Our next question, it's a fill in the blank question. Listen, complete the following sentences. See, why we have to learn these kind of questions. These kind of questions will give us the complete knowledge about a device. Okay, listen. A fuse is a short piece of wire of high dash. See, it has high specific resistance. Specific resistance. The symbol will be this one, but never ever use only symbol in the exam. Along with the expanded form, if you use the symbol, that is always fine. Never use only the symbol without this word. Okay, then with high specific resistance and material, right, and material of low melting point. This is important. Low melting point. Okay. Second question B. A fuse wire is made up of alloy of lead and tin. Fuse is made up of lead and tin. If the current in a circuit exceeds the current rating of a fuse wire, it melts. What happens if the current exceeds the limit? The fuse will melt. Next, this is what we learnt in basic question, correct? This is all these things we have learnt in concept video. That's why I am writing it directly. Next, a fuse wire is connected in. See how the fuse wire are connected with live wire, whether in series or parallel. It is always in series. Okay, and to which wire it has to be connected? It should be connected to live wire. See, all these are facts about fuse. Any one definite question will be as in board exam, so you should know everything about fuse. Next, higher the current rating, dash is the fuse wire. It should be thick. More the current rating, the wire inside the fuse should be thick. Next, live wire is also called as, it is also called as phase wire or line wire. Anything is fine. See, live wire has three different names: live, phase and line. Anything you can write it in the exam. Our next question, why is the fuse wire fitted in a porcelain casing? See, assume this is the fuse metal, fuse alloy we are using, fuse material. This material will be safeguard, okay, with the porcelain. This part, this box is called porcelain. Okay, why this has to be safeguard with the porcelain? Why? Because porcelain is almost an insulator. Okay, it is almost an insulator which will not affect the working of the fuse. So insulator will never affect the working of a material, correct? So porcelain is a insulator which will not affect the function of fuse. Our next question, two fuses wires are used, 5 amperes and 20 amperes. So there are two fuses, 5 ampere and 20 ampere. Okay, which of these is thicker and longer? We know current rating is directly proportional to the thickness of the wire. If the thickness is more, current rating is more. See here, which has more current? This one, right? That means it has high current rating. More the current, this will be thicker. Okay, so 20 amperes current rating fuse is thicker compared to 5 amperes. And we are talking about which is longer. We know, we have learnt in concept video that fuse wire does not depends upon the length of the fuse wire. So fuse wire does not depends upon length of the fuse wire. That means the current rating of the fuse wire never depends upon the length of the fuse wire. So both 5 amperes and 20 amperes are of same length. Okay, they have same length, but 20 amperes, okay, is thicker, 5 amperes is thinner compared to 20 ampere. More the current rating, the thickness will be more. Our next question, a fuse is rated 8 amperes. Can it be used with an electric appliance of rating 5 kilowatt and 200 volts? Listen, power is given as 5 kilowatt, that is nothing but 5000 watt, correct? Then voltage is given as 200 volts. 200 volts. Now current rating of fuse is 8 amperes. Okay, this is the statement. What do you mean by this? If the current exceeds more than 8 amperes, this fuse will melt. So they are asking, can this fuse be used in this circuit? So in this circuit we don't know the current, correct? If we can calculate the current, then we can aram say whether this kind of fuse, the fuse which has a rating of 8 amperes, can be used in this circuit or not. This is the main point about this question. Okay, so they have given the current rating, we have to find the current in the circuit. If both, okay, this whatever the current we are finding, that should be less than this one, that should be less than the current rating of the fuse. If that is the case, we can aram say use it. If the current here, okay, in this circuit is more than the fuse, then there is no use of using the fuse. First we will calculate the current, then we will talk about that later. Okay, listen. Using power and voltage, how we can find current? See, this is what we have learnt in electricity chapters, correct? So those are the same formulas, we are going to use it here to find the answer. So P is equal to V into I. This is the main formula. Using this one, I is equal to P by V. What is P? That is 5000 by 200. 2 zeros, 2 zeros. So this will be 25 amperes. 25 amperes. See, 25 amperes of current is flowing through the circuit. If you connect a fuse of 8 amperes, see, 25 amperes of current is running. If you connect 8 amperes rating, okay, the current, okay, the maximum capacity this fuse can hold is 8 amperes. More than 8 amperes, what happens? This fuse will melt. So whenever you connect 8 amperes to 25 amperes, 8 amperes rating fuse to 25 amperes circuit, definitely it will melt immediately. So you have to keep on changing, and that is not at all possible. So the answer for this question is, we cannot connect the 8 ampere current rating of fuse 8 ampere in this circuit. Now you got to know the reason, because the current flowing in the circuit is 25 amperes. Okay, definitely it will always melt the fuse. Our next question, what is the color code for the insulation on live, neutral and earth wire? See, if you don't color code also, it will work as usually. Normally it will work, but why do we need color code? Why? Because whenever there is a repair work, okay, whenever there is a repair work, whenever the electrician comes, when he opens the circuit, he will identify which is earth color, which is earth wire, live wire and neutral wire based on its color. So it has to be color coded in a different colors. So for live wire, it has to be brown color. Okay, brown color. The neutral wire will be light blue and the earthing will be yellow or green. These are the color code for different wires. Our next question, name the color code of the wire which is connected to the metallic case of the appliances, switch of the appliances. For these things, first you need to understand what kind of wire it is. See, which connection will be done to the metallic body of an appliances. For a metallic body of an appliances, it is earth wire. Correct? Earth wire. The second one, switch of the appliances. Switch is always connected to which wire? A live wire. So first we need to crack this one, then only we can write the color code. See, so color code can be asked in this way also. Color code can be asked directly, which color is there for, which color insulation is there for live wire or earth wire or neutral wire. That is direct question. These are the application oriented question. These kind of things you need to understand. So which wire will be connected to the metallic case of the appliances and where the fuse is connected, all those things. Okay. So for earth, we have already learned it should be green or yellow, and live wire it should be brown. Okay, these are the new colors which we are following right now. Okay, in earlier days the colors were completely different. What is a fuse? Name the material of a fuse. State one characteristic of the material used for fuse. There are three sub questions. We'll first define what is fuse. See, fuse is a safety device. Fuse is a safety device. See, this is the keyword. If you don't write this word, if this word is not there while writing the definition, definitely you will not get marks. See, when it comes to all the definitions in physics, there are some keywords. Okay, we will only look for those keywords. If those keywords are there, so and with a proper sentence, that is enough for us. You don't have to write exactly what is there in the textbook. For us, it is very much important is keyword. Using the keywords, if you form a normal English sentence, okay, any sentence is fine. So fuse is a safety device which limits the current, to safeguard the appliances, from faulty current. See, this is the definition of fuse. So don't by heart it, understand it always. See, fuse is a safety device. Why we have to use fuse? See, with the diagram I'll show you. This diagram is not necessary in the exam, but this will make you understand in a better way. Listen. Assume there is a computer. Okay. For a computer, we need to safeguard this computer. See, nowadays we are not using fuse. We are using MCBs in all our houses, but we need to, for the sake of this knowledge, we need to learn this. Assume there is an appliances computer. We need to safeguard it. How we can do that? We need to insert a fuse between a live wire and the computer. Now, here we have the fuse. Assume there is every wire will have some rated current. Rated current means the limited current. More than that definitely will spoil this computer. So what I'll do is I'll insert a fuse. Fuse is a safety device which is used to limit the current. See, whenever the faulty current comes more than the rated current, assume 5 amperes is the capacity for this current computer, more than 5 amperes will definitely damage it. So what I'll do is I'll take the 5 ampere rated fuse, I'll insert it here, so that whenever a current having more than 5 amperes, assume 7 amperes enters the wire, this fuse will melt. There will be a metal inside it. This will melt. So whenever this metal melts, there is no connection between this part and this part, so there will be no current flowing through it, and the computer will be safe. This is how the fuse works. We have some more questions. Okay, name the material of fuse. See, material we use is lead and tin. See, if we are using some different material apart from the normal material, in normal wires what we are using? Copper. Here we are not using copper, then definitely it has some different nature, right? That is what they are asking. What state one characteristics of the material, will tell you both the characteristics, that is very much important. Fuse should have a low melting point. Low melting point. If it has low melting point, then definitely it has high. What is this symbol? This we have learned in electricity chapter, right? High specific resistance. So it should have low melting point and high specific resistance. This is the symbol for specific resistance. So definition, material, and what is the nature of this material, why we have to use only this material only, that is the reason for this one. Name the device used to protect the electric circuit from overloading and short circuit. On what effect of current does it work? Very simple question. The answer is, this is the device which we use to protect the electric circuit from short circuit and overloading. So based on what effect it is working? It is working on heating effect of current. See, what is the symbol for current? I. This is what we have learnt in electricity chapter. See, this is the device which we use to protect the electric appliances. This works based on the heating effect of current. This is the principle of fuse. Our next question, how is a fuse put in an electric circuit? State the purpose of using a fuse in circuit. Very simple. See, how it is connected in a electric circuit. How it is put is nothing but how it is connected. It is connected, okay, fuse is connected in series with live wire. This is how it is connected. Then what is the purpose of fuse? Why we have to use fuse? That we have learned already. Our next question, a fuse is always connected in the live wire of the circuit. Explain the reason. See, if you understand the diagram, then it is easy to write the explanation. Listen, assume this is the mains and okay, this is the appliance. Okay, assume the fuse is connected here. Fuse is connected here. This is the live wire, okay, live and neutral. Assume the fuse is connected to the live wire. Now any faulty current enters, all the appliances are always connected to the mains through the live wire. So the current, high potential voltage will come from the live wire only. So it has to be connected to live wire, and they are asking why. If assume if the faulty current comes, it will safeguard the appliances. Now assume what if we connect the same fuse to neutral wire? Okay, this is neutral, right? Neutral, and this is live. High potential voltage always comes from live wire only. Assume the fuse is here. Okay, the fuse is here. Now assume the fuse is connected to the neutral. Now what happens when the faulty current enters from the mains through the live wire? This fuse will melt. This fuse will melt. Now see, the appliances is remained connected with the high potential live wire. High potential live wire, it is a problem for the appliances. So anytime in faulty current again it can enter. So it is not suggested to connect the fuse wire in a neutral wire. It should always connect it to the live wire only. So what is the main reason? Even though the fuse does its job, okay, fuse melts with the faulty current, the appliances remained connected with the high potential mains through the live wire. This is the reason. Our next question, how does the thickness and length of the wire, fuse wire, depends on its current rating? Okay, it's a very simple question. See, fuse, how this is related to current. See, this is fuse and current rating. Okay, based on the two factors, which is thickness. See, if the current rating is more, if the current rating is more, current rating of a fuse, current rating of a fuse is more, then thickness will be more. So current rating and thickness are directly proportional. See, in the exam you can write this sentence or the sentence in the bracket, anything is fine. This is a technical reason, this is the expanded form of this reason. So if the current rating is more, okay, if the thickness is more, that means if the thickness is more in the fuse wire, that means it has high current rating. Both are directly proportional. Then current rating is independent of length of fuse wire. So that means current rating will never depends upon the length of fuse wire. See, this is the main factor. This is length is not the factor which affects the current rating of a fuse. Our next question, explain the meaning of the statement the current rating of fuse is 5 ampere. This is very important question. Why? Because this explains the meaning of the fuse. See, the current rating of fuse is 5 amperes. What is the meaning of this statement? That means if the current in the circuit exceeds 5 ampere, then the fuse will melt to safeguard the appliances. So this is the function of fuse, right? If the current coming from the live wire is more than the current rating, then this fuse will melt to safeguard the appliances. Our next question, why it is not advisable to use a piece of copper wire as a fuse wire in an electric circuit? See, this question they may ask in different way also. Instead of asking copper wire, they may ask you aluminum wire, but answer for both the questions will be same, whatever we are going to discuss now. Listen, why we should not use copper or this one aluminum? Why? Because copper and aluminum will come in thicker wires. Thicker wires will have high melting point. So if we use thicker wire which has high melting point, even though there is a exceeding current, more than the required current, that is nothing but the rated current, so it will not melt, the fuse will not melt, then it will definitely damage the appliances. What is the use of fuse? Just to safeguard the appliances in case of high current, it will melt. See, even though it has high current, if we are using aluminum or copper, it will not melt even though there is a high current, because it is very thick and it has high melting point. Our next question, an electric kettle is rated 3 kilowatt and 250 volt. Give reason whether this kettle can be used in a circuit which contains a fuse of current rating 13 amperes. Yes, see, first the similar question only. Listen, first we will write the given data. See, 3 kilowatt is nothing but the power is given. 3 kilowatt is nothing but 3000 watt and the voltage is given. The voltage is 250 volt. Now they have given, they are asking, there is a fuse of current rating. Current rating of fuse is 13 ampere. So they are asking, can this fuse be used in the circuit which has a kettle? See, how we can do that? The similar method only. Listen, we need to find the current using these two. whatever the current we are going to find from these two data, if that value is less than this value, then we can aram se use it. This is the maximum current fuse can withstand. So it should be less than this one, then we can aram se use it. If whatever the current we are going to find using these two values, if it is more than the current rating of a fuse, we cannot use it. That will again spoil the fuse. Listen. So P is equal to V into I. This is the main formula to find current using power and voltage. So I is equal to P by V. P is 3000 and V is 250, 0, 0, 25 ones are 25, 12s are. So here the answer is 12 amperes. The current flowing in the circuit is 12 amperes and the fuse given is 13 amperes. Aram se we can use this in the circuit. We can connect the kettle for this fuse. Our next question, a switch is not touched with wet hands while putting it on or off, give reason. Okay, name the wire. Okay, this is the second sub question. First we'll answer the first sub question. Why you should not touch a switch with your wet hand? That is the question. Listen, when you touch the switch, okay, with a wet hand, what happens? The water will get connected to the live wire. We know water is a good conductor, correct? So when we have a wet hand, this water on our hand will get connected to the live wire. So there will be a connection. This will give us a fatal shock. Okay, this is very dangerous. So whenever you have a wet hand, never ever touch a switch. Then we'll go for the second sub question. Name the wire to which a switch is connected. Switch, not only switch, all the safety devices, switch, fuse, MCB, all those things should be connected to the live wire. A live wire or a line wire or phase wire. All the three means the same. So live wire, line wire and phase wire, most of the time we use live wire. That's it. Our next question, it is dangerous to connect a switch in neutral wire. Explain your answer. If they are asking it is dangerous to connect a fuse in a neutral wire or switch in a neutral wire, answer remains same. See, for this question we can answer through the diagram, but in the exam the diagram is not necessary. For your understanding I am writing the diagram. Assume this is the appliance and this is the mains where we are getting the power or high potential voltage. See, high potential voltage is always will come through a live wire. This is the live wire and this is the neutral wire. Okay, assume the switch is connected here. Now the switch is turned off, correct? The switch is turned off. Now what happens? There will be no current flowing through the circuit. But what is the main problem here? The appliances remained connected to the high potential voltage carrying wire, that is nothing but live wire. So in the live wire we get the high potential. Even though the switch is turned off, the appliance is always remained connected to the mains through the high potential carrying wire, that is nothing but live wire. So it is always dangerous to connect the switch, okay, in a neutral wire. This is the answer. Our next question, the diagram in the figure shows a 3-pin plug. Label the 3 pins, okay, and we have two sub questions. Listen, firstly label it. The upper one will be always earthing connection, and this one will be neutral and this one will be live. For this one only 1 mark will be allotted, and this question is for 3 marks. This is not required. For explanation part this is required. Okay, listen. Why the top pin is thicker and longer than the other two? Why the top pin, the earthing pin, is thicker and longer than the other two? See, for both the things they have a reason. Why it is thicker? Why it is thicker means, see, this is the earthing point. Okay, few students or few kids will be there, they try to connect it in a different way. So the earthing pin they'll connect it in like this also. So this earthing pin should never go to any other 2 pins. So it should always be connected to earthing only. That's why it is made thicker. Okay, that's why it is made thicker. So it should not enter into any other pins. Now why it is made longer? Why it is made longer? See, first thing is, whenever it is long, what happens? The first connection, it is going to get the first connection. So when it gets the earthing connection first, it is going to ensure the safety of the user. If the appliance, whatever the appliance we are using, okay, the 3 pin is coming from an appliances, right? So whatever the appliance we are using, if it is a faulty device, to ensure the safety of the user, this pin is made longer, the earthing connection. Once the earthing connection is gets the connection first, then that is safety for the user. Then why are the 2 pins splitted at the ends? See, like this. It is not completely a semicircle, right? It is splitted. Why? To make sure that it is fitted in the holes tightly. So if these 2 are not splitted, so all the 3 are not splitted, then there may be a loose connection. So if this splitted connection will give us the connection in a very tight way. Our next question: to which wire is the metallic case of an electric appliance is connected? Give the reason. Very simple question. See, this we have learnt already during the socket connection problem. Listen, to which wire the metallic case of an electric appliance is connected? Assume this. See, this question, to the metallic case of an appliances, the earth wire is connected. Earthing wire is connected to the metallic case, and they are asking for the reason. What do you mean by earthing? Earthing is done to safeguard ourselves. It is safe for the users. See, fuse is safe for the devices. Earthing is safe for the humans. Whenever a person touches the appliances, what he is going to touch? He or she, the metallic case. Metallic case is nothing but the outer case of the appliances. That is what we can touch, right? So whenever we touch that, when there is a fault, in the device, or there is a fault in the current, the high current will flow on the metallic case. So whenever we touch it, we will get a fatal shock. To avoid this one, earthing connection is given. So when the earthing connection is given to the metallic case, whenever the current flows through our body, it will go to the earth. So it will not affect us. This is the reason for this question. Our next question: the earthing of an electric appliance is useful only if the fuse is in live wire. Give reason. We have one more sub question. Okay, listen, this question we have learnt earlier, but this is asked in a different way. But answer for both the question is same. I'll explain you the previous question. We have learnt why fuse has to be connected always to the live wire. Correct. The same answer goes for this one. Here the earthing will be useful only if the fuse wire is connected to the live wire. The same answer we are going to write. Listen, this one, fuse, if we connect it to the neutral wire, what happens if we connect the fuse to the neutral wire? Fuse, when the high current flows, the fuse will melt, but the appliances will remain connected to the high voltage supply. So whenever the person touches the appliances, the current flows from the appliances to the person, it will give a fatal shock. And we have one more sub question. Name the part of the appliances which is earthed. We know earthing will be connected to the metallic case of the appliances. These are the 2 questions they have asked. Our next question: for earthing an electric appliance, one has to remove the paint from the metal body of an appliance where the electrical contact is made. Explain the reason. Very simple question. Why we have to do the painting for an electrical appliances? Listen, assume the metallic case. Okay, the earthing will be connected to the metallic case of the appliances, but for the metallic case only we are going to paint outside. Correct. Why? Because the paint gives an insulation. What do you mean by insulation? There will be no conduction of electricity. The answer for this question lies in the question why we have to paint the appliances. So painting the appliances is not only to make it look beautiful, it has one more application. See, what happens when you paint it? The paint acts as an insulation. Our next question: how does the color code of wires in the cable helps in house wiring? So why do we need the color code for different wires? That is the answer for this one. Listen, first thing is identification. To identify the different wires like live wire, neutral wire and earth wire, and connection of these different wires, to connecting to the different appliances. For example, metallic case. For metallic case, I cannot connect any wire. It has to connect it to earth wire only. So for a fuse, it has to connect it to live wire only. All these things we can identify using the color code. Our next question: what is the necessary to have an earth wire installed in power circuit but not in lightning circuit? Very simple. This is nothing but asking question why we need the earthing connection. Very simple. First thing is, why do we need earthing connection? See, we know appliances will carry high current or high power. It consumes high power. Consumes high power means it has high current only. So whenever it is having high current, it has to be earth or we will get a fatal shock. And what is the one more reason? The appliances may be expensive. So if it is not earthed properly, it will damage the appliances, then it will be of no use. That's it. Our next question: give two characteristics of high tension wire. This we have learnt in electricity chapter also. That's okay. We'll learn here also. The main property is it should have less resistance and it should have a larger surface area. See, in this question they are not asking for the reason, but we have learnt the reason in the concept video itself. Our next question: which of the cables, one rated 5 amperes and other rated 15 amperes are thick? Okay, out of 5 ampere wire and 15 ampere wire, which one is thicker? We know, see, whenever the current is more, keep this in mind, whenever the current is more, amperes is nothing but the unit of current, right? Whenever the current is more, that wire will be thicker. So this will be thicker. Okay, so whenever the current is less, okay, compared to these two, the current is less, correct? Assume we have one more, okay, wire of 3 amperes. This is the least thicker and this will be moderately thicker and this is the thickest wire. So this is how we are going to learn. So when the current is more, the thickness of the wire will also be more. Our next question, it is based on the diagram. In this diagram, they have given 3 bulbs, B1, B2 and B3, and we have 3 different switches, S1, S2 and S3. We have 3 bulbs, 3 switches and 2 cells, correct? So it is not battery, correct? It is a cell. If you combine 2 cells, then it becomes a battery. We have only 1 cell here, right, separately. So we have 2 different cells and 3 bulbs and 3 switches. Now this is the diagram. Now the question comes, see, out of 3 switches, how many minimum switches should be closed? How many minimum switches should be closed so that all the 3 bulbs should glow? Okay, to turn on all the 3 bulbs, how many minimum switches should be closed? Okay, first thing, to answer these kind of questions, you should analyze the question properly, whether the switch is connected to the bulb or not. That if you know our answer, we can answer. Listen, if I don't turn on this switch, if I don't close this switch, what happens? See, current will go here. Assume I will turn on these 2 switches. Okay, I will close these 2 switches. That means the current will start flowing from here and the current will start flowing from here. Assume, okay, I'll turn on, I'll close these 2 switches. Okay, now what happens? The current will flow from this one, okay, comes here and the current will go here and the same different current, okay, divided current will go here, correct? So these 2 switches will turn on. No, it is completely wrong. Why? Because see, when the current comes here, it will divide, correct? It will divide and this current will go back. So this bulb will glow, but what happens here? The current will not even enter. Why? Because whatever the current is entering, that should leave, correct? That should leave. When this switch is open, when this switch is open, current will not leave. It will only enter, it will not leave, though then this bulb will never glow. Only this bulb will glow. Okay, now we'll take the different scenarios. Okay, now we'll talk about these 2. Okay, these 2 switches, S2 and S3, will close these 2, S2 and S3. Now listen, this is open but these 2 are closed. So if this is open, no current will come from this cell, correct? Then current will come from this cell. See, from here the current will start flowing. Okay, here the current will not even enter. Why? Because whenever the current enters, it should leave, but here the circuit is open, so the current will not enter here. So the current enters here, so and bulb 2 will glow, and current leaves here. Okay, current goes here and will not even go here. Why? Because the circuit is open and the current will enter here. So bulb B1 will also glow and the same current comes here. Okay, so here the bulb will enter and leaves. So all the 3 bulbs will glow. Okay, all the 3 bulbs will glow with minimum number of switches, that is S2 and S3. If S2 and S3 are closed, then all the bulbs will glow. This is how you should analyze. Okay, what is the answer? Switch S2 and S3 are enough to glow all the bulbs. Now the second sub question, how these bulbs are connected. How these bulbs are connected? Listen, when the current is not flowing in this circuit, okay, in this path, when the current, see, from this cell it is glowing, right? So it is the current is starting from this cell. So current will only glows in this path. Current will only glows in this path, will not even enter this path. Why? Because the circuit is open. So we can aram se remove this connection. We can aram se remove this connection. So this is going in. How all the 3 bulbs are connected now? See, between these 2 bulbs, how many wires are there? Only 2. We have removed this wire, this path. Why? Because the current is not flowing. If the current is not flowing, we can remove that path. So bulb B1 and B2 are connected between 2 wires, between B1 and B3. These 2 bulbs are connected with 2 wires. If the number of wires, connected wires, are only 2, then all the bulbs are connected in series. How to identify series and parallel we have learnt in electricity chapter. If you have missed it, then definitely in board exam these kind of questions will only come, logical questions. If you don't know how to identify series and parallel, then it will be problem. So if the current is not flowing, we can remove that path. So this path is not there, so this is only this path, that is nothing but series connection. If this path is there, then it would have been parallel connection. Correct? So now there is no path, so there is no connection. That means no current is flowing. That means aram se we can neglect that path. So now the remaining path will be only this one, that is nothing but series connection. Our next question, describe with an aid of diagram. Listen, these kind of questions will not be asked in board exam. Why? If it is a block diagram, if it is a circuit diagram, then definitely they'll ask in board exam. Consider construction of fuse, all those things is not there in the syllabus, and these kind of questions will never ask in the board exam. So don't worry about it. Our next question, what is the purpose of a switch in a circuit? Listen, we have 2 more sub questions. We'll go one by one. What is the purpose of connecting a switch? So what is the function? What is the purpose of a switch? It is a on off device for current in a circuit. That's it. We'll go for the second question. Why is the switch put in live wire? See, why is the switch put in live wire? Why is the fuse put in live wire? For both the questions, answer remains same. Listen, again I'll draw the diagram, then you will understand it properly. Assume this is the mains, okay, mains, where we are getting the high potential voltage. So this is the live wire, assume, and this is the neutral wire, neutral, and this is the live wire, and here we have the appliances. Okay, appliance, and it is connected directly to neutral wire. Now in the live wire I am connecting the switch. What happens if I turn on? High potential voltage will go to the appliance. Correct? High potential voltage will go to the appliance. Now our answer, we can use it whenever we don't want, we can turn it off. What if I connect the same switch same switch in neutral. See, from live wire, this is live. In neutral, I'll connect the switch. Okay, this is the neutral. So what is the main problem happens here? Even though the circuit is off, okay, switch is off, this appliance remain connected to the mains with a high potential wire, that is nothing but live wire. So why the switch has to be connected in live wire? If the switch is off, the appliances will not be connected to the mains through the high potential live wire. If we connect the appliance in neutral wire, the appliance, even though the circuit is off, the switch is off, there will be no current, but this will be remain connected with the mains. So anytime any faulty voltage happens, any faulty current comes, that will definitely damage the appliances. So it is very dangerous to connect the switch or a fuse in the neutral line. Okay, then we'll go for the third sub question. What precaution do you take while handling a switch? Never ever touch the switch with a wet hand. So this is the precaution you have to take. Our next question, draw a circuit diagram using the dual control switches to light a staircase electric light and explain it working. See, the exact same question we have discussed in the concept video. That's why we are going to skip it. Nothing changed. Everything is exactly we have learned in concept video. Our next question, what purpose is served by the terminals of three-way pin plug? Draw the diagram and name the pins. Very simple question. What is the purpose of using the three-way pin plug? Just to connect it to electric supply. The purpose is connecting it to electric supply. This is the purpose, and this is the diagram. In the diagram, you have to make sure that, I know the diagram is very beautiful compared to your diagrams which you are going to draw in exam. I know, that's okay. So this one, earth wire, this is earth, neutral and live wire. Okay, live wire should always be on the left side. On the left side. If you get confused with the diagram, don't worry about it. You have to hold the switch like this. Okay, earth wire, live wire and neutral wire. The left side, to my left side, okay, is live wire and this will be neutral wire. The upper part, this will be the earthing connection. This earthing pin should be thicker, okay, compared to these two, and longer. Okay, this is how you have to draw the diagram. If this thicker and longer is not presented properly in the exam, you will never get marks properly. Our next question, draw a label diagram of a 3-pin socket. Say 3-pin socket, and we have to label the diagram. This is a label diagram, right? This is earth and this will be neutral and this will be live wire. That's it. Our next question, in the block diagram, we need to understand the question properly and answer the sub questions. Listen, this is the diagram given and everything is named 1, 2, 3. Okay, now we'll go for the question. Identify the live wire, neutral wire and earthing wire. So whenever you get the socket, first write the connection. This we have learned already, correct? So the bigger hole is nothing but the earth, the left side, okay, to us which is left, this one, correct? So this will be neutral and this will be live wire. First this identification if you do, then answering the remaining questions will be very easier. To which part of the appliances the terminal 1 is connected? What is terminal 1? So A is done, right? A is the labeling, that is done. B, to which part of the appliance the terminal 1 is connected? Terminal 1. So what is the terminal 1? That is earthing connection. Earthing connection is always given to the metallic case. Metallic case of the appliances. See, earthing connection is always given for the metallic case of the appliances, so that when you touch it, okay, when you what we can touch normally, the metallic case of the appliance, right? So when we touch it, you should not get shock even though it is faulty. So that is the main reason. The earthing connection is always given to the metallic case, the outer case of the appliances. Next, to which wire joined to 2 or 3 is fuse connected? Okay, fuse, we know, we have understood fuse is always connected to the live wire. Which is live wire here? 3. So fuse is connected to terminal 3. See, all these things are the basics we have learnt in concept video. That's why I always suggest, before watching the theory solution or numerical solution, watch the concept video first. That will give you some hint to solve the questions. What do you mean by the term local earthing, and explain how it is done? See, this question, with the help of diagram only you can understand it properly. So we have done some animation in the concept video. Watch it, you will understand it properly. This question, mainly this question, only few questions we are going to skip. Why? Because those are concept based videos and those require some animations. So that is done in the concept video. The link for the concept video for the same chapter, okay, household circuit part B, is available in the description box. Watch it, you will learn it. Our next question, a power circuit uses a cable having 3 different wires. Name the 3 wires of the cable, and we have few more sub questions. We'll go one by one. First one, name the 3 wires of the cable. We already learned this one many times. Live, line or phase wire. Live wire has 2 other different names, that is nothing but line and phase wire. So live, which are the 3 wires? Live, neutral and earth wires. Then sub question B, between which of the 2 wires should be heating element of an electric geyser be connected? See, every appliances, okay, should be connected to a live and neutral wire. Live and neutral wire. If it is using more power, then it will be connected to earth wire. So all the appliances should connect it to live and neutral. Keep that in mind. And if it is using more power, then it should be connected to earth wire. So they are asking about first any 2 wires, right? So any 2 wires will always be live and neutral wire. All the appliances, if I connect live wire, it has to be connected to neutral wire also. Everything, okay. Appliances, like appliances now, this one, fuse and switches will not considered as an appliances. Those are the devices, okay, functional devices. Appliances means geyser and TV, all those things, everything should be connected to live and neutral wire, okay. So live and neutral, okay. Then to which wire should the metallic case of the geyser be connected? Geyser, we know it will consume high power, so earthing connection has to be done. But where that should be connected? That is nothing but the metallic case. For the metallic case, which connection? Earthing. Earth wire or earthing wire, anything is fine. Next, to which wire should the switch and fuse be connected? So switch and fuse are not considered as an appliances, those are the functional devices. So switch and fuse should be always connected to live wire. If you connect these fuse and switch to the neutral wire also, it will do its job, but the appliances will be always connected to the high potential side, the nothing but live wire. So whenever you touch it, you will get a fatal shock. So fuse and switch should be always connected to live wire. Keep this in mind. That's it. Our next question, state 2 circumstances when one may get an electric shock from an electric gadget. We have one more sub question. Listen, first we'll answer this one. Which are the 2 circumstances? See, these are not the only 2 circumstances which we are going to learn. There are many, just we have to state only 2. See, in ICSE board exam, most of the questions will be asked for 1 mark. Okay, any question will be asked for 1 mark. Sub questions, there will be many sub questions. Each sub questions will carry more marks. So in this way only you have to learn. If you have any confusion, you have to see 2024 ICSE grade 10 board exam, then you will understand. all the questions will be of only 1 mark. So most of the answers will be of only one word. Don't write extra answers in the board exam. While writing extra, if you do something wrong, definitely you will lose marks. That's why write the precise answer. So state the 2 circumstances when a person get electric shock from an electrical gadget. Very simple. First, if the fuse, okay, if fuse is connected to neutral wire, if the fuse is connected to neutral wire, then if the live wire comes in contact with metallic case, okay, these are the 2 circumstances, okay, which is going to give us shock. Then they are asking what preventive measures must be provided with the gadget to avoid it. Very simple answer. These are the 2 answers. Then the next sub question will be proper earthing. Proper earthing will solve all these things. That's it. Our last question. See, this is the diagram based question, and if you know the concept, we can aramse answer it. See, bulbs, switches, a fuse and a socket is given. So now first thing we need to label the components. See, labeling is nothing but how many bulbs we have. We have 2 bulbs, so B1 and B2. We have 2 switches, so S1, S2. You can make this as S2 and this as S1. No issues with that. And see, this is not the AC symbol. You need to understand that the AC symbol will also be in the similar way only, but it will start at the beginning. If it is starts at the beginning, that means it is AC connection, that is AC current. If it is in the middle, that means it is fuse. So bulbs, switches, fuse, and this is nothing but the socket where we are going to connect with the plug pin. Okay, next, see, now we need to, labeling is done, then we need to color code the wires. Color code, see, if you want to color code the wire, we need to know which wires are this. What is the, okay, first wire, second wire and third wire. We need to know this one first. Okay, so see, if where will be the fuse will be connected, this is how you need to analyze. Fuse will always be connected to the live wire, correct? This you should know. Fuse will always be connected to the live wire. So whatever the connected wire, these 3, the third wire is live wire, and the live wire enters and goes back. The correct, the whatever the current enters, that will go back to the same socket using the neutral wire. So the one is nothing but the neutral wire. So always the current enters from the live wire and leaves through the neutral wire, correct? The remaining wire will be earth wire. So this is how you are going to analyze it. Now the third one, with how these 2 bulbs are connected. We know how to identify it. The one, see, these 2 bulbs are connected here, correct? Somewhere here. So one wire is coming, one more wire is from the bulb 2 is coming, and one more wire, that is nothing but the neutral wire. So how many wires are there at this point? 3 wires. If the connection is more than 2, then definitely it is parallel. If it is equal to 2, it is in series. This is what we have learned in electricity concept. The connection is in 3 wires, so it is parallel. That's it. So now we have completed all the theory questions. We have solved all the each and every theory question from this household circuit part B. Before this one, we have learned the concept video. See, once we finish all these videos of all the chapters, we are going to solve each and every question paper. Okay, since 2017. We are not going to discuss in 2017, these are the questions from different chapters. No, we are going to learn from chapter wise. That means this is household circuit, right? From the household circuit chapter from 2017 till 2024, what are the questions are asked? Okay, we are going to learn answer for those questions also. This is what we are going to do after solving all these videos. Those videos will also be available in the description box once we finish all these videos of all the chapters. So in all the videos, in all the chapters, what we are learning, first concept video, then we are going to solve each and every theory question from the textbook. Which textbook we are following? Selena 2025 edition textbook. Next, we are going to solve each and every numerical from the textbook from each and every chapter, so that you are going to learn everything. 99, almost 90% you are going to solve. Remaining 10% will be logical questions. If you have this concept, okay, this much basics, aramse you can solve any question. My suggestion is watch all the videos to learn everything. Thank you.